Electrochemistry, the new chapter. First, already we learned that as electrochemical cell. What is that electrochemical cell? You will learn in class 11 that is the redox reaction. The redox reaction, just a connecting of this electrochemistry. First, you must know that Daniel cell. What is the Daniel cell? That is the construction of the functionating. That is cell converts to chemical energy liberated during the redox reaction. For example, that is zinc, solid zinc reacted with copper sulfate, that is Cu2 plus aqueous, to converts zinc 2 plus, that is zinc sulfate aqueous, and the copper solid. That's mean copper is deposited. Here, for example, that Daniel cell having the electrodes of zinc and copper dipping in the solution of their respective cells like this. Suppose this one contain, so this contain copper sulfate CuSO4, and this contain, there is copper sulfate SO4, and this is zinc. See here the solution containing like this, they connected with what? The salt bridge. This solution containing with salt bridge. So this is electrode, this is a zinc electrode, and this is a copper electrode. So that here the copper is deposited here, copper deposited here, and the zinc is deposited here. So this is the zinc sulfate and this is the copper sulfate solution. This is the salt bridge. So connecting of these two, so the direction is like this. So this is the salt bridge. So the electrical energy and has the electrical potential is equal to what? Here 1.10 volt. Already you know that in class 11. This means the zinc and the copper 2 plus, zinc 2 plus ion and the copper 2 plus ion is unity. So such device is called galvanic or the voltaic cell. Okay. Suppose here the electron flow. Suppose the electron flows zinc rod to copper rod. The current flows will be copper to zinc. So that means the E external, this electrode potential external is less than 1.1 volt. Suppose E external is greater than 1, that is 1.1 volt, means here the electron flow from copper to zinc and current flow from zinc to copper. Okay, so zinc is deposited at the zinc electrode and the copper is dissolved at the copper electrode. Suppose when E external is equal to 1.1 volt, means here no flow of electrons or current, similarly no chemical reactions occurs. Okay, this is the basic thing. Just I remember that. Then the galvanic cell. When the electrochemical cell that converts to chemical energy of a spontaneous redox reaction into the electrical energy, that is in this device, that is the Gibbs energy of the spontaneous redox reaction is converted to the electrical work, which may be used for the running a motor or other electrical gadgets like heater, fan, geyser, whatever it is. So here the already we discussed the Daniel cell, that is zinc, solid zinc react with Cu2 plus ion, that is an aqueous, to give zinc 2 plus, and that is zinc 2 plus aqueous and copper solid. Here this reaction is a redox reaction. So here this individual half cell reaction, that is reduction of one species undergoes in a redox couple, one species undergoes oxidation and another species undergo reduction. The first is zinc converts to zinc 2 plus, so that it undergoes oxidation process. Similarly Cu2 plus to Cu, that is reduction, it undergoes reduction. Okay, so here we can write the half cell of the reduction half reaction and the oxidation half reaction. So here the reduction half reaction is Cu2 plus aqueous, then how many electrons are gained here? 2 electrons. Then it converts to Cu solid. So this is reduction half. Reduction half reaction. Then suppose in zinc, loss of 2 electron, it undergoes oxidation. So zinc 2 plus and 2 electron. Okay, this is oxidation. Oxidation half cell reaction. Now this couple is called the redox couple. See, copper electrode maybe that is called in reduction half cell, and the zinc electron is the oxidation half cell. So we can construct the innumerable number of the galvanic cell and the pattern of the Daniell cell by taking the combination of the different half cell. That is, each half cell consists of a metallic electrode dipped into the electrolyte. Already we seen that diagram. That is, the two half cells are connected by the metallic wire through a voltmeter and the switch externally. Then the electrodes of the two half cells are connected internally through the salt bridge. Look at like this. So already we've seen here. So salt bridge, this is the salt bridge and this two electrodes. So solution. Okay. Then sometimes the both electrodes are dipped in the same electrolyte solution, and that case you do not require the salt bridge. Okay. So the each electrolyte interface, there is a tendency of metal ions from the solution to deposit on the metal electrode, trying to make the positively charged. At the same time, metal atoms of the electrode have the tendency to get the solution of ions left behind the electrons at the electrode, trying to make the negatively charged. Okay. So at the equilibrium, there is separation of charge, and depending on the tendency of the two opposing reaction, that is, the electrode may be positively or negatively charged with the respect to the solution. So here the potential difference developed between the electrode and the electrolyte is called electrode potential. Electrode potential means that is potential difference. Here the potential difference between the electrode and the electrolyte. Okay, this is called electrode potential. Then when the concentration of the all species involved in the half cells is unity, then electrode potential is known as standard electrode potential. Standard electrode potential. Here then the standard electrode potential reduction that is that is called standard electrode potential in a galvanic cell. Half cell in which the oxidation takes place is called anode, and the negative potential with respect to the solution. The other is the half cell which reduction takes place, called cathode. Look at this. So reduction, this is cathode, this at cathode, and this is oxidation, this at anode. Okay. Then already you know that the direction of the current flow, okay, the potential difference between the two electrodes, and so on this, that is the switch on the position of the electron flow from negative electrode to positive electrode. The direction of current flow is opposite than the electron flow. That already you learned. Then the potential difference between the two electrodes of the galvanic cell is called cell potential. That is potential difference between the two electrodes of a galvanic cell. So that is usually they are measured in volts V. Okay. The cell potential is difference between the electrode potential of the cathode and anode. So this is cell electromotive force, or simply we can write it EMF. Okay, that is EMF of the cell when no current is drawn through the cell. That means it is now accepted to convention of that we keep that anode on the left and cathode on the right, okay, anode on the left, cathode on the right. So just simply we can write it like this. Suppose a galvanic cell generally representing by putting a vertical line like this. For example, writing of the copper reaction, copper and silver. For example, Cu solid plus 2 Ag plus aqueous gives 2 Cu2 plus aqueous plus 2 Ag solid. So we can write that cell reaction like this: Cu solid single line, Cu2 plus aqueous double line, then Ag plus aqueous single line Ag solid. So here this is electrode and this Cu2 plus is electrolyte, and here Ag plus is electrolyte and this is electrode. So two electrolyte solution connected with salt bridge. So this double line indicate salt bridge. Okay. Suppose for E cell, already we can write it, that is E cell is equal to E right minus E left. R indicates right, L indicates left. So we can write this following cell reaction here: Cu solid, copper solid plus 2 Ag plus react with to give Cu2 plus and 2 Ag. So half cell of the reaction is, you can write it here, which is undergoes cathode and which is undergoes anode. That is, which one is oxidation, which one is reduction, you have to find out. The Cu2 plus oxidation, and this Ag2 plus 2 is reduction. So we can write it the half cell reaction here, that is the cathode. Cathode means what? Reduction. At cathode, reduction. Here which one is undergoes reduction? Ag. So 2 Ag plus aqueous, then how many electrons are gained here? 2 electrons. So it gives 2 Ag solid. So this is for cathode, and anode is, the remaining is what? Copper. So copper undergoes oxidation. So Cu solid to converts to Cu2 plus aqueous, then 2 electrons are lost. Then you can write it like this. So copper electrode and electrolyte, then this is E right hand, that is for anode left, then cathode, so that E right minus E left, so this minus this. So you can write it like this. So you can see already, you know that for example we have, that is, we can write it for this reaction: E right minus right is what? Here in this side is right, so we can write it E cell is equal to ER minus EL. So here we can write it E Ag plus 2 slash Ag minus E left, E Cu2 plus 2 Cu. Okay. So this is then the measurement of electrode potential. Measurement of electrode potential means here the individual half cell cannot be measured. We can measure only the difference between the two half cell potential that gives a EMF of the cell. See here the half cell called, that is the standard hydrogen electrode potential, that is represent for the platinum electrode dipped in that hydrogen gas is released here. Platinum solid single line, hydrogen gas double line, hydrogen H plus aqueous. So this is here assigned, this is a zero potential at all temperatures. Corresponding the reaction is what? That is H plus aqueous 1 electron to converts to half H2 gas. Here that values already you have seen in that class 11. This is standard electrode potential at 298 Kelvin. It values reaction oxidizing strength and reducing strengths are given. You can look at this in book. So here the standard hydrogen electrode consists of a platinum electrode coated with the platinum black like this. So here the electrode is dipped in a acidic solution and pure hydrogen gas bubbled is throughout. See, look at this. This is the hydrogen gas. So the concentration of both reduced and oxidized form of the hydrogen is maintained the unity. That is, this implied that the pressure of the hydrogen gas is 1 N and the conversion of hydrogen ion the solution of 1 molar. So this is the 1 molar solution. At 298 Kelvin, the EMF of the cell, the standard hydrogen electrode, that is the second half cell, the constructed by taking the standard hydrogen electrode as the anode, that is the reference half cell. Okay, and other also half cell is the cathode that gives the reduction potential of the other half cell. Okay, so if the concentration of oxidized and the reduced forms of the species in the right hand and half cells are unity, then the cell potential is equal to the standard potential. That means the standard electrode potential you can write it E naught. That is E naught is equal to E naught R minus E naught left. Okay, for standard hydrogen electrode is 0 for left, so that hydrogen is 0. So E naught is equal to E naught R minus 0. So is equal to what? E naught R. Okay, the method of the EMF cell is PT solid slash hydrogen gas, that is in 1 bar. Okay, the pressure is 1 bar line, that is H plus aqueous, that is 1 molar. Then double line react with the copper Cu2 plus aqueous, that is 1 molar, and Cu. Okay, Cu solid. Here this measured value is what? 0.34 volt, and it's also value for the standard electrode potential of the half cell corresponding to the reaction is what? Cu2 plus aqueous, that is 1 molar, then 2 electron gives copper solid. Okay, similarly the measured EMF cell is already we know that there is PT platinum solid single line hydrogen gas 1 bar, then single line H plus aqueous 1 molar, double line zinc 2 plus aqueous 1 molar, then single line zinc. Here this is the salt bridge. Okay, here the measured value is minus 0.76 volt, that is corresponding to the standard electrode potential. So here the zinc 2 plus aqueous 1 molar reduces to, gain 2 electron to zinc. Okay, the positive value, look at this, this is the positive value of the standard electrode potential in the first case. Look at this case, and the Cu2 plus ion gets reduced more easily than H plus ion. This reverse process cannot occur. Okay, then the hydrogen ion cannot oxidize it. Then copper under the standard condition that is are known. Okay, then the copper does not dissolve in HCl. In nitric acid it is oxidized by nitrate ion and not by hydrogen ion. Okay, the negative value, look at this negative value, the negative value of standard electrode potential in the second case, like that indicates that hydrogen ions can oxidize as zinc. Okay, see that's convention of this left electrode, that is zinc solid converts to zinc 2 plus aqueous, that is 1 molar solution and 2 electrons. Similarly right electrode is Cu2 plus aqueous 1 molar gives 2 electrons gain to copper solid. The overall reaction, the cell sum of the above two reaction already you get, that is zinc solid plus Cu2 plus aqueous gives zinc 2 plus aqueous and Cu2 plus Cu solid. So here E naught cell is equal to E naught right minus E naught left. So E naught right minus E naught left, that is E naught right is positive value, that is zinc plus 0.34 volt minus into minus of 0.76, so it will give 1.10 volt. Okay. Sometimes the metals like platinum or gold are used in the inert electrodes. They do not participate in the reaction but provide their surface for the oxidation or the reduction reaction for the conductions of electrons. Okay. Example, platinum used hydrogen. Okay. Thank you, student.